Hey guys, today we're going to switch from surface area to volume. Volume I think you're going to like better than surface area. It's a little easier to calculate. It has a few less steps. So let's talk about the difference between surface area and volume. In surface area, we were dealing with the area of the outside faces. So if we're painting a room, putting siding on a shed, anything to the surfaces, wallpapering a room, something like that, okay? Now, volume is the amount inside of it. So a few summers ago at the swimming pool, they did a whole bunch of work inside the pool. They scraped all it down and they repainted the inside and the floor. That would be called surface area. They had to find the surface area of the big pool to know how much paint to buy to fix all the problems they were having at the pool. But if we were to fill it with water, the amount of water that the pool holds, that is volume. So volume is how much something will hold, okay? And it's measured in cubic units. So I always bring this out. So the amount of cubes that fit inside of a shape. So it depends. If you're wanting to know how many cubic centimeters, then you would have little bitty tiny cubes, 1 centimeter by 1 centimeter, and you'd figure out how many cubes would fit inside that shape. Or let's say you're wanting cubic feet. Well, then you would have 1 foot by 1 foot cubes and figure out how many 1 foot by 1 foot cubes fit inside of the shape, okay? These are probably 1 inch by 1 inch cubes, so we're probably going to be finding cubic inches here, okay? So volume, I could take this all apart and count every single cube one by one, but that would be kind of silly. So volume, we calculate, okay, you've probably learned volume is length times width times height. And that is great for a rectangular prism. That's the only shape that it works for, though. So I kind of try to change your brain a little bit when you get to me in 7th and 8th grade. Instead of just thinking, oh, volume's length times width times height. Well, that's not going to work for cylinders. So we need to think about it in a little bit different way, okay? So I'm going to do length times width and figure out how many cubes are on this bottom tier here. So this is 1, 2, 3, 4, 5, 6. By 1, 2, 3, 4, 6 by 4, which is 24, okay? And so now I want to know how many tiers are there? Well, there's 24 in this tier, 24 in this tier, 24 in this tier, 24 in this tier, and 24 in this tier. That's 1, 2, 3, 4, 5 tiers. So 24 times 5, I'm going to punch that in because my brain doesn't work real fast, is 120. So there's 120 cubes here, and I didn't have to take it all apart and count it off one by one, okay? So what we just did is we did area of the base times the height. So we did length times width times height, but I want you to think of it as doing area of the base times the height. Okay, now if I was with you in class, I would make you go like this with your hand. Area of the base times the height. And then that will work for more than just this shape, okay? So let's look at a few examples here. Here we have a rectangular prism. So we're going to do area of the base times the height. So 6 times 8, that's 48. And then I got to take back times, that means there's 48 little cubes could fit 1 inch by 1 inch cubes would fit on the bottom tier. Well, this 3 over here means that there's 3 tiers. So I'm going to take that times 3. So 48 times 3 is 144. And then volume we label as cubed because we're doing inches times inches times inches. So that's 3 of those. So we're going to label it with 144 inches cubed. Okay. I also want to look at triangular prisms today. So notice this one is the exact same dimensions as this one. It's just being cut in half diagonally. Okay. So I'm going to still do 6 times 8 area of the base times the height. So 6 times 8 gives me 48 times the height, which is 3, and that's going to give me 144 inches cubed. Well, should these two volumes be the same? We did area of the base times the height, but would the same amount of popcorn fit in here as what would fit in here? No, this one's going to hold a lot more. So we have to remember to divide this one by 2, okay? Because this has been just cut in half. So I'm going to divide by 2. 144 divided by 2 would be 72 inches cubed. Okay, so that works fine. I do want to just talk to you about triangular prisms, and I may need to angle this down so I got a little bit more room on there. So I know this triangular prism is not the exact same triangular prism as what we're looking at here, but you can tip them up on end and stand them like this, okay? So let's just imagine that I tipped this triangular prism up on end, and now the triangle is the base, okay? So I would find the area of the base. So it's like I just took this and tipped it up, okay? So 6 times 3 is 18, but area of triangles, remember we have to divide by 2. So 18 divided by 2 is 9. So I'm going to do, and I hope I'm not running out of room. 6 times 3 is 18, divided by 2, that gives me 9. So that's the area of the base this time, because remember I've tipped it up on end, and now my height is 8, so I'm going to do 9 times 8, and that would also give me 72 inches cubed. So kind of two ways to think about that on triangular prisms. You can leave it like this and think of it, oh, it's just a rectangular prism that's been cut in half. Or maybe you could tip it up on end and use the triangle as your base, okay? Feel free to go back and look at those if I went too fast, okay? I do want to look at cylinders today as well. So this is the whole reason why we can't just think of volume as length times width times height, because cylinders don't have a length or a width. They kind of have a height, but that would be about it. So here I have 2 cylinders. So let's look at this one. Now remember, surface area of a cylinder had a lot of steps and was a little bit tricky. Volume's much easier. Okay, remember we just do area of the base times the height. Except for this time, our base shape is a circle. So we have to remember how to find area of a circle. Well, area of a circle is pi times radius squared. Pi times radius squared. So I'm going to do 3.14 times 5 squared. So 3.14 times 25. That gives me 78.5. That's the area of the base. Pi times radius squared is the area of the circle. Now I just have to take that times the height. So times 3. 235.5 feet cubed. Now anytime I talk about volume of a cylinder, for those of you that are farmers and ranchers and deal with animals a lot, I always think of like the stock tanks. How much water does that stock tank hold? And maybe you have a 10-foot tank or a 12-foot tank or whatever. How much water does it hold? And so that would be, it would hold 235 and 5/10 cubic feet. Now you could convert that to gallons, and then that would maybe make more sense in your head, but that's what it would hold, okay? Now I tipped this one over on the side on purpose because you see those water tanks that farmers or ranchers maybe are hauling around to go fill up stock tanks, and so this is how it would be sitting on their trailer. So if we want to know, well, how much cubic feet of water will this water tank hold to haul around to all of the animals? Well, we can still do that. I'm going to picture this, though, like sitting like this. That's not a shape for its base. It's a curved side. So we've got to imagine this is tipped up on end and use the circle as the base still. So I'm going to do pi times radius squared again. So I'm going to punch in 3.14 times 3 squared because the diameter is 6 this time. So 3.14 times 9, and I get 28.26. And so if I have it tipped on end, my height is now 10. So 28.26 times 10, and that gives me 282.6 feet cubed. And there we have it, okay? All right, go back and watch some more if I went too fast. Remember, volume is area of the base times the height. All right, good luck. Go watch some more if you need to.